Um, so, Good morning. My name's Simon Mudd. I work at Booking.com. I'm a senior database administrator there. The talk today really is just talking about something that JF was talking about earlier, which is replication lag, where it comes from and how to handle it. And the thing that basically, I guess, hopefully you haven't seen, but I guess most of you will have seen at some point in time, which is you write to the master, you have some slaves, and you suddenly see that they don't have the data that's up to date, which you expect them to have. Same problem as JF, so I don't know, don't move my head, don't move my body, don't know what it is. Anyway, so that basically the end result is that your slaves don't have the data which you expect to see, and that usually confuses the applications. So, have a quick talk about booking, then basically some of the issues involved in replication lag, how to approach it, how to monitor it, and some thoughts afterwards. So I guess most of you probably here earlier said that you'd seen replication delay and you've managed replication, so I will cover slightly a couple of things that JF mentioned earlier, but hopefully that should just be for anyone that missed the talk earlier. So just a quick thing about booking. I guess a lot of you have heard about us. We were based in 1996, so it's been around for a while now. It used to be a startup, but I guess that's not really the case anymore. The website is in a large number of languages, in 40 different languages. We have properties in over 100 countries, and also now covering flights, car rentals, and expanding some of the coverage of different things. And the employee-wise now, we've grown a lot over the last 10 or 12 years that I've been working there, and there's over 20,000 employees in nearly 200 offices worldwide, so quite a large growth, and that's, I guess, well, hopefully we've been trying to do something which other people find useful. So, at MySQL at Booking.com, we started small. We had a few MySQL servers. We also use MariaDB. And we added a few more because we had a bit of a load. We added a few more, and these days, well, we have thousands of MySQL servers, both, as I say, MySQL and MariaDB. Most of them, I think probably 90% of them involve replication. There are a few like clustered setups which are individual shards where the application handles especially, but that's like special use cases. And we have basically like 100 or hundreds of different clusters, with more than 20 of the clusters having more than 100 slaves. So JF was saying the same thing. We have more than one data center. Clearly, if you want to survive your data center going down, and they don't normally go down, but they might do, then you have to have more than one. So we have multiple data centers, and we have to cover the service over multiple data centers and handle failures in any location. So scale-wise, there's quite a lot to manage. It keeps us quite busy. In terms of replication, well, Jeff mentioned that earlier, but just to repeat that very quickly, we use it for scale out. Clearly, we have a lot more people looking at our website to look at hotels and accommodation they may want to reserve than those that actually end up reserving it. Ideally, everyone that looks should reserve, but that hasn't happened yet. So we tend to have a lot more slaves than masters. Replication involves the writing of the changes on the master. That gets transactionally onto which get pushed out onto the slaves, and there may, in our case, there may often be intermediate masters as well there. And obviously, one of the things that is mentioned, MySQL replication is asynchronous. So you write something on the master, and what you're absolutely sure about is at that moment in time, it is not on slaves. You have to wait a short period of time. That period of time may be short, it may be a few milliseconds, it may be tens or maybe hundreds of milliseconds, but there is a delay, and your applications, if you read from slaves, have to be aware of that. So one of the things that often with replication is forgotten is that the multiple zones. You may have a large number of slaves, and then sometimes if you have a large number of slaves running from a single master, network bandwidth may be an issue on the systems you're using. So in the past we were running with a 1 gig network card, and when we had like 50 or maybe 100 slaves off that server, every 1 megabit per second that you push out through normal transactional activity, you push out 100 times that because you have 100 slaves. So your network bandwidth can be a problem. These days, obviously, at least on bare metal boxes, 10G is quite common, and that really does make a lot of the those type of issues go away. But not everyone's on bare metal, not everyone's running 10G, so sometimes network bandwidth can be an issue. And I guess if you're in cloud, and sometimes you don't even see what bandwidth you have. That's also not always visible, but it can be a concern. And then the other thing is that sometimes we're upgrading, so we may be running right now 8.0. If there's a 9.0 or an 8.1 or something, we might want to upgrade some servers. So the replication topology is never quite as simple or flat as one might expect. But the point is, if you have intermediate masters, you get extra lag, and that causes potentially extra issues which may not exist if you just have master to slave replication. So first thing to understand about, you have to measure lag, so yeah, it's good to know actually if your slaves are behind. So how do you find that out? The typical thing a lot of people do is do slow slave status. There's a column that's called seconds behind master. That's great, it tells you it's 0, but it lies. So sometimes it tells you something that's true, but often it lies. So if you start doing that, and that's the thing you're supposed to use, well, at least initially people look at because it's the obvious thing to look at, then be careful because it doesn't always tell you the truth. There are quite a lot of cases when it does say it's 0 seconds delay, and actually the server may be processing a very large transaction, may take time, and during that period there is delay, but you can't see it. So be careful. And also, if you have intermediate masters, the lag that's shown with seconds behind master is only behind the current master you're talking to, not the upstream master. So the best way to actually measure lag is to inject an event periodically into the master, the upstream, the top master, and then basically read the latest event that you can on the slaves. That basically tells you that the last event I've seen from the master is whatever period ago it was. You could inject very frequently. One of the things we still use the event scheduler, so there's no extra processing involved, and that just basically injects an event every second. And so the only problem is your resolution of your replication delay is then basically at maximum 1 second away from the actual delay. I think GitHub have mentioned on some of their presentations they I think are quite intolerant to replication delay, so I think they inject every 100 milliseconds, and but they do that with an external process. And then basically you just run something on the slave to read the delay. One of the things that's worth bearing in mind, and I'd certainly suggest you do that if you're doing something similar, is use the 5.7 and later option, which is the max execution time, to basically limit the query time for the read. The reason for that, if anything blocks, sometimes things block, then you know that your query will not get stuck and never respond. It will at least give you an error if it can't complete the query within the second in this case. So it's good to do that. And I've seen replication get stuck for all sorts of bugs and things like that. And so basically the slave polling thing would also generate errors and also potentially use up connections to the server being queried. In 8.0 there's a new feature which allows you to directly query the upstream master, the delay from the last transaction from the upstream master. That gives you microsecond resolution, which is nice. But and you can also, it also tells you if there is an intermediate master, the delay behind that. So you actually can see 2 tiers of replication delay if you have a tiered structure. Excuse me. But it only works with 2 tiers. If you have more tiers, you only see those 2. So the intermediate master you're talking to, and then the top stream master. But it's good, but it still requires a heartbeat injection to give you those values. So it would be nice if the guys at Oracle, or maybe even if MariaDB had a similar feature, that the heartbeat that's used effectively as a measuring lag actually didn't necessarily inject GTIDs because that has its own issues, but did provide a way to allow you to not have to inject it ourselves. JF showed we use Orchestrator for replication management. JF mentioned that earlier with a couple of his slides, so you can see a typical setup here, which is this is with 8.0. Orchestrator's actually, if you have time to set it up, I'll certainly recommend it, because if you have more than a few servers, and even if you only have a few servers, simply because visually it's very convenient. Anyone can see there the different colors because they're different data centers or availability zones, so you can see quite clearly which is the master, which is the box here on the left. You can, the blue dots, this is an aggregated view, so basically there will be multiple servers under on the right hand side. The number of servers normally is actually indicated by Orchestrator with a number there, but I've just blanked that out. But you can see immediately, there's 5 or there's 10 or there's 100 or slaves at the back here, because if you open that up, then you suddenly get a much wider view, and sometimes it doesn't fit on the page. Often what you want to do is see that. So that's very convenient, and we use that for managing a lot of our replication, partly for the visibility thing, which is good for the non-DBAs, but also for the failover recovery situations, which we see. JF showed this earlier. Nice thing about Orchestrator, you can see, there's replication delay. The boxes that have gone orange, they have replication delay. Why they have it is a separate discussion, which we'll come into to how to measure that and things. But the nice thing is that you can immediately see these servers have replication delay, or we need to do something about it. And you can see that Orchestrator does make that visualization quick and easy. You don't have to go and check each box individually and things like that. And you can see if it gets worse, oh my God, all my slaves have replication delay. So usually if you're using replication, you're writing to the master, you're probably reading from the boxes on the right hand side there, and all of these have lots of replication delay. Oh my God, it's the end of the world. But that's how you would that's one way of visualizing it, and that's very convenient. And then we come to, okay, we've got replication delay, but why? And basically usually that's that the transactions being handled by the master can't be pushed fast enough to the slaves. Usually that's basically, replication replication can be multi-threaded. By default it's single-threaded, which is inconvenient, so you have to remember to set it up to use parallel replication. Sometimes the transactions are basically keeping the system very busy. And so you can usually the actual replication, the write load on the master is sufficient that you can't get all the things pushed through onto the slaves sufficiently quickly. The other thing that can cause replication delay is things like doing alter tables. An alter table on a 1 gig table doesn't take very long, but if you have a 100 gig table or a terabyte table, it may take several hours or several days. And that will basically just stop replication, because while that's happening, nothing else can happen. The next thing can't happen until the previous one's complete. So and drop tables can also cause locking and things, and sometimes take some time, and they can also block replication. So basically these are things which you have to be very careful of. Don't overload the master too much, or at least overload it with enough transactions that can't get through to the slaves. Don't do DDLs, because they will basically stop everything replicating through, and you have to find ways to work around that. And that comes back to the solution. Okay, so what do you do to prevent that? So I think the first thing that really you have to be aware is, if you have developers writing software for you and you're using replication, basically you have to explain to them, this is a shared resource. You can't write whatever you want. You have to be aware of the others that are writing as well. The reason for that is that usually you can say, okay, this guy's doing a few things, that's fine, but then someone else writes a few things, that's fine, and somebody else writes a few things, that's fine, and somebody else, or maybe you've got a cron job at 3 in the morning that's copying some systems and data or modifying some data. And if they all do things at the same time, maybe individually none of them cause any problems, but if they happen to be doing things at the same time, they will cause problems. So the developers need to be aware that the resources on the server, and if they don't share it wisely, they will interfere with each other. That's really the big thing to understand. The second is that if you actually get to a point that you really can't make replication work fast enough, then you maybe have to look at other options. One of them can be to split the servers into 2. So you have 2 clusters of systems rather than 1, and that reduces the load usually by a factor of 2, so that's better. The other option, which as I say, is you can enable parallel replication. That makes a huge difference, because replication, initially at least, is single-threaded. being single-threaded means you can do multiple transactions in parallel with master, but if you don't touch anything in the replication configuration, that gets processing in a single-threaded manner on the slaves. So clearly you're not doing this efficiently. Once you enable parallel replication, then you can often get similar throughput and parallelization compared to what's done on the master. So that's very good. The other thing is large transactions take longer to process on any server, whether the master or the slave. So it's much better to do smaller transactions, maybe 100,000 rows changes at one time. They get processed in a few milliseconds or something, and those changes then get pushed through replication to the slaves. So optimizing the batch size often depends on what you're doing, but smaller chunks are usually better. Adding a bit of delay is always a handy thing to do. And then the other thing is make sure that the applications also read and check whether they're generating delays, or if there is delay in the systems. So one thing that often developers, at least that we've seen, forget. They say, okay, I'll just do it slowly, so I know I can't be affecting anybody, but there may be something else going on. If they actually see that there's replication delay and they don't need to write, or they can delay writing, then doing that won't make things worse. So that's something that's quite important. The other thing is that if you need to do DDL, so if you need to modify schemas, then there are tools like PT Online Schema Change. There's also Ghost from GitHub. They work very well. They are replication aware, so they won't overload your systems, but they will generate extra load on the servers. So while they're running, changing some table in the background for you, the other processing that you're doing may be affected by that. So you may still need to slow down because you have something like PT Online Schema Change working, and you're also doing other things. So the bottom line really is make sure the developers are aware that they're sharing the resources with other people, make sure that they do things in small batches, make sure that potentially they add a few bits of delays between making changes they're doing. And if they measure delay as well, then basically that should make everything work fine. But we could also come back, and this is something which is not in MySQL or MariaDB right now. We could come back and say, well, hang on a second, why isn't there tooling to do this for us? I would like to tell MySQL, do as much as you can, and prioritize these things or prioritize those things, or limit the changes by user, or limit the changes on a table, the number of changes that can be made by the size of the changes. So a lot of these things that I list here aren't available at the moment. It would be nice if they were provided, but clearly if that sort of tooling were available, it would have to be low impact, so it doesn't affect anyone, because you can make the most complicated system possible, but if it was slow and slowed actual normal processing down, then it wouldn't solve a lot of people's problems. But it would be nice to have that. So that would be something that maybe for board people, having a framework to allow that. Maybe the audit plugin could be used that, because that can be pushed in when changes are being made to actually detect different things. That would be nice. This is basically quality of service handling for databases. It doesn't exist, and it would be nice. And if it existed, probably the talk that I'm giving and other talks that are similar and related would be a lot simpler, because you wouldn't have to worry so much. But you have to be careful also. If you want to delay writes because someone's doing writing too heavily, then you can also cause pile-ups. So it's not always as easy to actually achieve this, even if it would be nice to have it. And then we come back to the consequences of replication delay. So you suddenly find that you've got it. What's the problem? Well, there are some situations where perhaps it doesn't actually matter. A lot of booking, a lot of the developers say, well, we can't have we don't want replication delay. It has to be, everything has to be as fast as possible. Of course, we don't write, the DBAs don't write to the database. I don't know about you guys, but we don't write to the database. The developers' code writes to the database, and the people that book the hotels trigger writing to the database. We don't cause replication delay. They always come to us. And that's sometimes a bit frustrating, because you go, oh, hang on a second, but I didn't do anything. And if you're in the similar situation to us, then sometimes that's a bit frustrating, but you have to, this is one of the things that's there. So if you have delay, it may be something like someone changes the description in our world of booking of a hotel description. This is a nice place by Barcelona with a nice view of the port. And they decide to add a few more words because I think it's a good idea. And there's a replication delay of 2 hours. Who's going to care? It doesn't matter. Replication delay is irrelevant, because the description may not be exactly right, but it really doesn't matter. So in spite of not wanting to have replication delay, for some things it may not matter. For other things, maybe you're changing your email address or something and you want to, and then you go and look at the page and it's not changed. Well, hang on a second. So you go and change it, but it's changed. And then you go and look again, it's not changed. That's not a good experience for a user. Hotels provide us with rooms which we can offer to the public. So if they say, well, I'm going to offer 10 rooms, and they change that to 5, or they have 5 and they want to change it to 10, and they go and have a look and they see the wrong value, that confuses them, they try again, they get confused, they'll call some of our support people and say what's going on. That's not good. And then of course, I make a reservation and I go and look and it's not there. That's not good either. So clearly, and every business has its own particular versions of this. Clearly, replication delay in some cases is really not good. Sometimes you can be okay with a second, sometimes a few seconds. It really depends on the business, on the model and everything. But those things are not good. And I think one of the things that you have to be aware of here is then you have to say, okay, if we have it, how are we going to handle it? So that's the big question, which the mentality you have to basically have as a developer is, it will happen, so what are you going to do about it when it happens? Because you can't just ignore it and then say, oh, I'm going to generate an error. Or if you can recognize there's a delay, then you can actually, and I was saying about how you can measure it, if you can recognize the delay, then you can say, okay, I can perhaps warn this data may be out of date. I can do something. But really, the developers often have to be aware of this and then consider whether they actually want to do anything, don't want to do anything, and what they do if they see it. Of course, one thing you can do is you can say, oh, there's replication delay, let's go to the master. That's easy. There's a master, we know it's up to date, let's go and talk to that. JF was talking about this a little bit earlier, but basically don't do that, because the reason you have slaves is because you can't scale the workload on the master. So by going back to the master, you'll just kill the master. And if you kill the master, then you have no business. You can't take writes, you can't take reads, and basically everyone gets upset. And your manager will come along and say, don't do that again. So there are cases when you can do that, but you have to really, really do it very carefully, and you certainly can't do it for all reads. So there may be some cases that you're about to do a transaction, and you want to be absolutely sure that the data is up to date, so you want to go and read from the master, that's okay. But clearly you can't do it if your normal read scaling is quite high compared to the number of the load on the master. That wouldn't be very good. So basically, the other thing that also is possibly not good to do is basically have a couple of boxes of replication delay, because sometimes, as you saw in the picture earlier, it's not always every single system. It may just be one system or another system. So, oh, I've got replication delay here, I'll go and try that guy over there. So what happens? All the reads coming here suddenly go over there, you overload the box over there. So now you've got 2 boxes of replication delay because they're overloaded. And then you say, okay, we won't go here or go there, we'll go this one over there. So what you do is you can take out everything, and then everything has replication delay. So that may not help either. It may be okay. Again, it depends on what you're doing and how your applications behave. But it may well be that, again, the best thing to do is basically accept that you have replication delay and handle it in one form or another. Often that works. And I think usually, if you think about it, in a lot of cases, you can usually handle it, and it's not such a big deal. You may want to internally go and poke someone and find out why it's happening and what to do about it. See what systems are generating too much load. But I think the bottom line is, yeah, don't just go and read something else, because you can cause more problems. You just push the problem from one place to another, and that doesn't actually make anything better. One thing that can be done, though, because of types of load, we often, and I guess other people often, have the interactive load, the real time. You want to get something that's now, but also you have some batch reporting that has to do heavy queries. JF mentioned this earlier, but that's basically the same thing there. So split the load from one type of application that does heavy queries to talk to different set of servers that do fast interactive queries. Because we have so many servers, we often split our pooling basically per groups of applications. So often an application has its own group of dedicated slaves to talk to, so it can only affect itself. So if it goes mad and does too many queries, or it does them inefficiently or something like that, the only application that's affected is the application that's overloading its own slaves. This can also be the other thing is that the reason your slaves are overloaded is because you're doing inefficient queries. Your tables are not structured properly. Your design of what you're doing is not done very well. So the other thing to look at, which is not really mentioned here, but is to be aware of, is the design of your schema, your tables, your access patterns, your indexing. All of these things are really important. And if you structure your tables and your access patterns sufficiently well, the chances of overloading the systems is much lower. And that's obviously better, and therefore the chance of replication delay and things goes away. So, as mentioned, there are certain systems, certain applications which can handle replication delay. So, if you're doing DDLs, PT Online Schema Change and Ghost both know about replication delay, and they will basically slow down if there is delay, so that's good. The other thing is that if you're using proxy SQL, some people use it and they like it a lot. We don't use it very much, but that's not because it's bad, just simply because we're fine without it. But one of the things that proxy SQL allows you now to do is to basically detect boxes which have a delay and ignore them and only talk to ones that don't. So that may be a way of just avoiding the problem. So it's a nice thing to have. So what do we do? So the basic way that we handle replication delay is to use what we call waypoints. We effectively write a marker into the replication stream when we make a change, and then we go to a slave and basically wait for that marker to appear, because we know that once we've seen that marker, then the data in the database on the slave is as up to date as it was when we made the writes. Therefore, everything that we read on the slave will be completely consistent, and that works quite well. In terms of implementation, basically that's right. So we have a small table we call DB Waypoints. We basically write a row of data in there, and that gets committed, and then basically we go and read on the slave, looking for that particular row. That's a nice simple point select to read to see if it's there. If it's not there, you wait a short period of time and try again. Eventually the row will be there, and then you can go and do the other selects you want to do because you know your database is up to date, and that works fine. Obviously you want to have some sort of timeout. You don't want to wait forever, and if you have got a web page behind this or something, you may wait 3 or 4 seconds or 5 seconds. That's probably okay-ish, and if not, okay, you have delay, so you have to handle it. So you still have to handle the problem, but this is making sure that in most cases you wait a short period of time, the data's up to date, and then you can just read information, refresh the page with information that you want to show, which is now up to date with when you made your write. And we basically, and then we have some background process, which basically in batches will remove those waypoints. We don't want to go and do another delete of the thing we just inserted, because then we double our I/O rates. So that's not a good thing to do. So you want to do the batch deleting, is just something but delete the old rows periodically. So the batching and things is just basically the easiest way to handle the writes and things is make sure you use small transactions. As I said, that may be like 100 or 1,000 rows, something like that. It often depends on what you're actually doing, and also you may be writing into several different tables, which often happens when you're making changes to things. And also sometimes it's good to include a small delay between the changes that you make. That allows basically things to catch up. And also allows other writers to have time to push data in while you're sleeping. And then again, you go back to the slave, you check that the writes have arrived, and then you know that basically everything's fine. So that's good. But there is one thing that certainly with our implementation at the moment, not all slaves are the same. Because of load on different groups of servers, replication may be running faster on some systems than others. So occasionally we do see that we may be checking one particular slave and there's no replication delay there, but unfortunately there is some replication over there. So that could be something that we could improve. In practice it doesn't happen very often, so we've not really bothered about it, and because we have a large number of slaves, actually polling and the application being aware of all the slaves requires more effort, because you actually have to maybe poll 50 slaves or 100 slaves, check them all, check which they're all up to date and things, and that's probably not really something you want to do. There's an alternative that's probably which we've not actually got round to trying, but one day I might have a go at that, is something called Freno by GitHub. And that basically allows the app, what it does is it basically says, I want to write, can I? And Freno says yes or no. And there's some configuration in there. And then it says, okay, well, I'll write. And then it goes, I want to write, can I? Or no, and maybe Freno says no. So you have to wait, then you try again. Can I write? Yes, you can. So it's a bit of a cooperative thing, and I think the DBAs can control which apps can write more and less. But that's good. The only thing for the scale, when you have thousands of servers and things and the number of pools and clusters we have, that I'd have to see exactly how well that scales, because Orchestrator we use is pushed quite heavily to its limit because of the scale we run at. And I think Freno possibly might have similar considerations. And I think the reality is that the current system that we're using works. It's simple, it's easy to understand, everyone understands it, and the number of issues it actually generates right now is small enough that it's hasn't needed to be fixed. Other things that you can do, until recently these didn't really exist, but what you can do now is you can, when you write your transaction and commit, you can get your last GTID position. This also works both for MySQL and for MariaDB. MariaDB support's been more recent, but MySQL's had it for some time. So when you commit to get your last transaction, you can get the GTID position, which is like the last reference to the transaction state, and then you can go and listen on the slave and say, I want to wait a second to see if you've picked up this change. And you don't have to write anything extra because you know which GTID set to which state of the master database that you're in, and that will work. And that actually works quite well. So that's good. The only inconvenience here is this depends on support in the MySQL or MariaDB library, and I believe the two implementations are incompatible. So that's a shame, because the actual idea here I think is very nice, and it would be nice to actually have the libraries were compatible, and obviously the function names to use, you have to know whether you're talking to MariaDB or MySQL when you wait for the GTID set to appear on the slave that you're listening on. The other thing I mentioned, Proxy SQL, is that Proxy SQL also has a way, if you don't want to have a master connection and a slave connection, you can use something like Proxy SQL, and Proxy SQL can be told, it can be aware of the state of the master, of all the servers it's reading and the state of the slaves, and it will basically only let you poll the slaves which are as up to date as the master that you've written to. And that's actually quite nice. So that means that you don't actually have to do anything special. What you get is consistent reads, and that's very nice. So I think the other thing is that clearly when we're writing to the master, it'd actually be nice on the master to know if the slaves are up to date. But you can't tell because the master doesn't know if the slaves are up to date, which is a shame. But it would be nice, because if you knew that, then you could basically not write, because you knew that the slaves were not up to date. But there is a plugin, but something that's very similar is semisync. So semisync basically says, before committing something, I will make sure it gets to at least one slave. You can obviously configure this, and then I will, when that transaction's reached there, then I will tell the client that the transaction's made it. And you sort of want something similar, like do something similar, but tell me when the slaves are up to date. And there is a patch which was available from MariaDB, which called the No Slaves Left Behind patch, which effectively provides that. So that was written by Jonas Orland, Google, and basically when you get where the semisync works, it basically comes back and it says whether the slaves are up to date. And I think something like this potentially could be modified to actually provide the sort of functionality, which would be nice on the master to say, okay, I want to write this and tell me once all the slaves are up to date, because I think it might slow things down, but it might also mean that you don't actually have to do very complicated monitoring outside of the actual server itself. So it might be convenient. The implementation details would be interesting, but it might be something which would be nice. So you've got lag. Oh my God, we've got lag. What are we going to do? So usually, because someone calls me, we've got lag in our server called BP. What are we going to do? We've got lag in BP. So the first thing to do is go and find one of the slaves that's behind. Go and see what is it doing. So I use pstop, which I wrote, which is actually a very convenient thing for looking at the activity of the server. It also tells you where the server is waiting on writes. So basically, where is its I/O bottlenecks and things. So with that, you can tell, oh, this table and this table and this table. And usually those are the tables that are effectively being written to very heavily or being read from very heavily. Often you see updates can cause lots of problems because updates require reading from the disk to update the value if it's not in cache. And sometimes what you find is you've got some big table, the data's not in cache, someone starts updating something, so you have to pull it off the disk, that slows you down, then you're updating it, then you're writing it, and you're in a loop like that. The other thing it can be happens is that someone creates a table and they don't actually add a primary key. No one ever does that, but they do. And when they do that, it's great, because when you insert all your data, you've got like 10 gigabyte table, it's fine, it's tiny, no problems at all. You insert 10 gigabytes of rows, and then you on the master, you just have some batch thing that operates and changes 10 gigs changes some column or something. But we're now in row-based replication where your primary, oh, no primary key, so every single row does a table scan. So 10 gigs of lots of rows, table scans, and you suddenly find all your slaves are millions of years behind, and you can't fix it because there's no primary key, and it has to scan the primary key to update the row. And so it does a table scan for every row to change it. So that happens, it's happened to us. MariaDB has an option, and so does MySQL now, for forcing a primary key to exist on a table. Don't ever, 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 if you use replication, allow non-primary keys not to be enabled. You can sort of have unique keys, but really just use a primary key, because sometimes people say, I don't need primary keys. On a single server, maybe you can get away without it, but in replication, it's really, really bad. And apart, so you can look on the server, you can see which tables are busy and things. And the other thing that probably is worth doing is to look at the last few minutes of the bin logs, scan the bin logs, you need to do some processing on that, find out which tables are being modified, and then probably compare that to our previous times, and you can see where the load's coming from. Once you've identified the tables generating replication lag, then you basically hopefully can find the user that does writes to those tables. Bin logs generally these days, if using RBR, don't have any information about the user that writes or about the actual statement that was written. So you can enable annotations on the bin logs, which allows you to see the query that was used. And I know that in some of our queries we include as comments like the user or the application or the process or something like that. But normally with RBR, you don't actually, that all gets lost, and you certainly don't see the MySQL user that was used, which for auditing like this would be very convenient, because then you go, oh, it's that user, it's this guy over there, let's go and talk to him and find out what he's doing. But usually once you know the table, you can figure out who to poke. Go and poke them, tell them to stop writing or slow down whatever they're doing, and then usually things get better. And then it sounds silly, and I'll just repeat this, but MySQL and MariaDB by default don't enable parallel replication, which is like really stupid. Because if you're doing replication, unless you're doing it for your as a toy, you want it to be as fast as possible. And these days, parallel replication does work, really. So make sure that you use parallel replication. The configuration, of course, is different because the implementations are different, but use conservative or optimistic. There's differences depending on whether there are likely to be conflicts or not. And if you're using MySQL, use write set. Write set is really, really efficient. It's much better than logical database or logical clock or database. Write set really works really, really well. And in fact, you can get write set to actually apply the logs faster than it could have been applied on the master. So that's really good. So make sure you enable parallel replication. But then I guess if you're really concerned about delays and things, maybe you don't want to use asynchronous replication at all. That's obviously a decision that you need to know what you're doing and why you're doing it and everything else. So it may be, and there's a big maybe, it may be that maybe you need to look at MySQL cluster or Galera or InnoDB cluster, because they don't have replication delay because they're a cluster, they're synchronous. And that makes your life much better. But there are scalability things and all sorts of other differences and how they fail and everything else. So clearly you need to understand the differences, but it might be something that's at least worth thinking of. And the commit rates, and also if you want to go across multiple data centers or availability zones or something like that. So, but it's something you should think about, because if you can't handle, or you don't like replication delay, then that makes it go away. It may bring other issues, but it makes it go away. So So just to summarize very quickly, basically, measure if you have a replication delay or you've seen it and you must measure it. If you can't measure it, then you can't see it and you don't know what's there. Make sure you don't do DDLs, use online schema changes to avoid that. Perhaps add delays when you're batch stuff, add delays, or small delays, obviously not like 10 seconds or anything, just small delays between writes. And then obviously make sure that you configure your servers properly. The other thing, of course, is that hardware is much better these days than a few years ago. So depending on whether you're in the cloud or you're on bare metal or whatever, if you've got fast networking and you've got very fast storage, then a lot of these problems go away. But it depends on the hardware you're using. So be aware that the hardware can help a lot, but you have to configure it, and obviously for replication you can also have to configure that. There are ways to, as JF said earlier, to make replication more efficient, or at the scale of maybe losing data if the server crashes, and that can be something which may be worth considering. So there are lots of different options there, but yeah, things to consider. And yeah, I don't know, any questions? Okay, well, thank you.